All right, moving on then. So we're going to start doing the other hardware pieces, but again, I want to just kind of stop for a moment and make it abundantly clear to you all what the limitations are of doing it with this method. So it works really fast. Okay, so that's like the very first like awesome thing about it, because it just automatically populates all of the hardware on these particular planes in all cases. However, if you look at it closely, you'll see that the geometry gets skewed. Okay, so basically as I modify this, the geometry itself will change. So if it gets kind of squished, then whatever used to be a circular element is now an elliptical element. So that's just something to be aware of. Point 2, I think, is what I had this at. Yeah, so that's just something to be aware of. If it's important that everything be properly sized and scaled and everything like that, then you need to basically find a way to put it in that particular location in that size, and that's what we're going to look at next. But so if I'm going to try and get this to be a little bit more actually circular, I'm probably going to reduce the U minimum here to like a 0.85. Oh no, that's actually not good. I'll just leave it at 0.8. It's probably good that way. It's good enough for my purposes anyway. So basically, when you're doing this, you have to do it a few times in order for it to work properly. And the challenge really is whether or not you can run things through the same process, or if you have to duplicate the entire thing. So the simple way that I'm going to do this is to create a surface output with a wireless connection here, and then it's going to be just a lot cleaner. So I'm going to do it with the surface param, and I'll name it datum surface. Actually, I'll call it sub dv datum surface. Plug that in. You can call it whatever you want. That's just what I'm calling it.
Is it going to do the first subsurface?
Yes, first one. All right, so I made that a wireless, and then I'm going to plug this in here. So that way this whole thing just becomes fully autonomous here. So now I can select this stuff and move it away. I'll clean it up so that it becomes much, much smaller. There we go. And then simply put, I'm going to group that, and then just make a copy of that whole group 4 times. Looks pretty clean, right, guys? Okay. Well, the other part that you will have to do here is to modify the actual numbers. The numbers can be modified a few different ways, and one of the ways that I encourage you to think about doing it is through mathematical principles, basically your simple arithmetic that helps you limit the number of changes you have to make if you ever have to make a change. It also helps to keep alignments done properly. So the way I'm going to do this, starting off here, is I'm going to take my, well, let me kind of draw it. I'll draw it out this way, right here. So, and you guys don't have to do this, but I want you to just understand what I'm doing. So I have a panel that looks like this. I also have a line, right? So basically, when these things are moving proportionally, I'm moving a certain percentage down this way, and then I'm moving an additional percentage down to the other side. So basically, if I want everything to be symmetrical on each of these panels, then I want it to move the same amount from here to here that I want it to move from here to here. Okay, so you guys can do that mathematically using the same sliders. You know what? In this case, it's not all that, it's not imperative, and frankly, when you're doing something that's like a dynamic surface, you're not going to have to be doing these calculations anyway, because every single number is going to be automatically generated. So I'm not going to bother with that. Let's just go with this. I need to turn some of this stuff off. In fact, I'm going to turn it all off except for the last item, the morph. And I'm going to turn all of this stuff off as well. There we go. So I left on the fin, I left on the subdivide surface, and the last piece, the morph. So the next one I want to do here is the vertical one, or the one that's relocated on the vertical side of the panel. So notice how this one right here was a value of 10% of the panel in height, and it was located with a spacing of 10% of the panel away. So if I have to do that from the other side of the panel, then ultimately I'm going to take these numbers and invert them to be you know, a 10 and then a 20, because it's 10% away and then it's 10 wide. So I'll start off by jumping this one, keep doing that, to 0.1. Oops. You'll notice it's going to look pretty crazy. And then this one is going to go to 0.2. All right, simple enough, right?
So wait, do you have four total?
4 total, yeah.
You're working on the first one.
Yes. No, sorry. The second one now. That's this one. 10.2.
So what's the first one?
The first one is what we just had.
Right.
Yeah. First one stays where it is. So now the second one, then I relocated up to that location. So you guys are kind of understanding the relationship here a little bit. All I did was change its position by changing its proportional values to put it in a new location.
I just have a question. Is there a relative place that they have to be placed in? Like a certain distance from the edge?
Yep, that's what this determines.
No, but I mean like an actual... Is there like a...
You mean an actual construction?
Yeah.
Oh yeah, your engineer will go through and tell you. I mean, basically your facade engineer is going to have all that information. Yeah. So that was number 2, and then let's go through and do the other ones here. So the other one, I'm going to take this one in the bottom right. That's where it exists right now, and I'm going to move it over to the other side. Now, when I move it over to the other side, that particular geometry is no longer going to be facing the proper direction. So I'll show you what I do for that one. But in order to move it to the other side, we have to invert the opposite values that we just inverted in the previous one. We need to invert the values on the V direction instead of the U direction. So here in the third box, we start at 0 and we end at 0.2. So if the values start at the edge and then end 0.2 away from it, if we're going to invert that to the high end, we have to change this to a 1. And this changes to a 0.8. Still a difference of 0.2, we just slid it up the scale to the other side. So what you need to be aware about this, guys, is that the morph, while it moved it to the other side, it didn't reorient it. So if you're curious about how to do that, that's why I included 2 hardware pieces. I included two because this one is the one I just referenced previously. But I made a competing one here because I knew that I wanted them to face opposite directions and I wanted them to connect roughly in the same spot. So ultimately it's, oh, I have the grid on, hang on. Grid snap, turn that off, there we go. So ultimately these are supposed to connect here on the surface box. So that's why I have them sort of facing opposite directions. So that basically means instead of the previous brep, I need to set it to the opposite one instead. So now I'll zoom out, and you can see that this one now faces the opposite direction. You see that? So then jumping down to the very last one, the last one is still currently in the bottom right corner. So I need to change three things on this. I need to change the U-min and max, the V-min and max, and I have to change the brep. So I'm going to first change the brep. So I'll right click and say set one brep, and I'll select the opposite one down there. And then I'll change these values. So again, this is going to be a 0.1. Oops. And then this will be a 0.2. And then I need to slide everything to the other side of these sliders. So the Vmax is going to be a 1. And Vmin is going to be a 0.8. And to kind of, simplify this here and just look at the whole system that we generated, basically what we did is we created an entire 10-story, so to speak, or pretty much 10-story, an entire 10-story facade complete with hardware components in very little time.
The only problem is on the outside, or on the edges, there's still some facing that way.
There shouldn't be. Mine are facing in.
Oh, okay.
So if yours are facing the opposite way, then you need to revise in order to get it to face the proper way. Any other questions about this before I make sure you're all caught up and we take a little break and then move on?